Hi and welcome. So I had a viewer question that I will attempt to answer today, which is something I probably should have done the first time around with my mods to the Harbor Freight press, because this press, I put an air jack, a jack with an air motor on it to speed up moving large distances, large displacements with the jack. And the question was, will the amount of force that the air motor provide be equal to what you can get even with my extended handle here on the jack manually? So we're going to test that out. But before I do that, I discovered something interesting here, and that when I was doing some of these other projects, I noticed that there was slight angles to the parts that were bridging the two plates here, and that's because the two plates don't meet up at the same height. So I need to take these off and machine them down to be equal thickness. And fortunately, when I made the pins, when I did the pin section that aligns them on here, I made them press fit with a slight interference fit so I can push them out. So I'm going to pop these pins out. We're going to take it over the milling machine. I'm going to face both sides and make them equal thickness so that they line up nicely. Part of the problem could be the paint on the top of this, but I don't think so. Also, having gone to Harbor Freight recently, I noticed that they made a significant change to their 20-ton jack. You can see the deformation here where I've applied the 40,000 pounds and it permanently deformed it. It hasn't gotten any worse, but that's kind of unfortunate. The newer ones have a big plate of reinforcement here, and the cross piece here attaches with bolts to the uprights. So they've made significant changes to their 20-ton press. It's a better change, and it seems like they watch these things and get viewer feedback and make slight adjustments to get a better product. So good on them. I need to really reinforce this because the 40,000 pounds, this thing really does flex. But we're going to be testing that again today. And first, we'll just go over the Arbor Press, pop out these pins, and machine it down so that these two plates are equal thicknesses. I also have these other two plates down here that are just pieces of plate steel, hot rolled, and maybe cold rolled. And I just use them, and that's how I discovered this, because I tried to slide it over and they can't. And depending on how the things are oriented, it can be off by as much as 1/8 of an inch, so that's no good. These are not cast iron. I know a lot of people said in the past they were. Another improvement Harbor Freight made. These are hot rolled steel or cold rolled steel like those, probably hot rolled. So here's my setup for the Arbor Press. I just had the Arbor Press in a vise, and the pins are only a slight interference fit. They struggle a little bit coming out, but not bad. So I've got a 3/16 inch pin. I'm just using it to push out the 1/4 inch pins. I'm going to machine these down, and I'll pop the pins right back in. I never had my Arbor Press permanently mounted anywhere, and still don't, so right now it's sitting in a vise. First pass, I went a little bit fast and pushed a cutter. There's 30 thousandths depth of cut and 500 RPM. No lube. But the interface lines are nice, can't feel them. So we're getting a good cut. The chips are coming off blue, and as you can tell by the curly cues, they are definitely not cast iron. After facing off the sides of these plates, I used a C-clamp to the bandsaw table to hold it on. It works even better. Okay, we get the pin started. Then to control depth, I've got this piece of aluminum thick wall tubing. Just set it over the pin, press it till it stops, and they're all identical. And we're ready to go on to our test. Alrighty, so we'll repeat the test we've already done. We have the two plates I just flattened, some additional support plates just to raise it up to make it easier. Load cell with the pieces I made in the other video. And we've got the pump here, the hydraulic bottle jack. And we're going to start applying some pressure. So there's the readout in the load cell. That was just the weight of it, essentially. It's screwed down onto the load cell a little bit, so there's a little bit of pressure. And actually the load cell, look at just the weight of this alone is enough to increase pressure. That's kind of entertaining. The load cell itself is accurate to plus or minus 50 pounds because it's a 100,000 pound load cell. So that's 0.0 something like 2%. Anyways, all right. So let's just make sure it can still get the goods going here. Oh, man. I gotta tell you, it's pretty tough to do this by hand. Ugh. But we can get there. There's 40,000. And then it leaks out pretty quickly. Okay. So we all thought it could do that, right? So next up, we're going to apply some air pressure here and see where it'll go. The question from the viewer is, can you get to maximum pressure with air compressor air feeding the air motor on the bottle jack? Well, I don't know the answer to that. Let's find out. All right, so the air compressor is just cycled, and we're going to give the air motor a shot here. It's good up to 120 psi. Focus, you little wanker. All right, so we've let the pressure back out. We're going to try the air motor now. The air motor is good. I don't know if you can read that, to 120 psi. And we're going to try the air motor and see how high a pressure we can get. So the compressor just cycled, so I'm at maximum pressure. So it stops around 30-some thousand. And it looks like it peaks out at about 37,700, 38,000. My air compressor is around 120 psi, 120, maybe 125, maybe a little under that. It's actually maintaining this pressure, which is pretty good. So the answer is, it doesn't make it all the way, although the handle that comes with the hydraulic jack, you wouldn't be able to get there either. This is a much longer than normal handle by about another 6 inches or so at least, if I remember right. So, interesting test. Thanks for watching. Hope you find it useful. Hope to see you next time.